All right, so here's your assembly, and I know it's a work in progress, but there's lots of stuff that can just be pulled around that isn't really properly assembled. And at that point in time, it should actually be so that what I usually do when I build assemblies, the first thing I do after importing a component for the most part is assembling it. So now, of course, every time you use that position capture feature, everything that has moved. So even if you just drag this around, well, you can't drag it right now because it's not properly assembled. But if you drag this whole thing around, if the sliders would be assembled, everything that has moved since the last move feature is recorded in the next, not move feature, but position capture feature, is captured in the next position capture feature. The bigger your assembly gets, the more data is stored in there. And in the end, that'll just slow your assembly down. You might have noticed that already. I can assure you, if you assemble this properly and get rid of all these capture position features and all the ground features that you don't need, you will notice that your assembly is like twice as fast and the timeline is only half as long. Anyway, let's step back in time here and roll the history marker right to the first. I think that's the first component. No, that one is. So that left beam, that is going to be your stationary assembly. So what you could use, you could just go ahead and ground it. And that would actually work, right? Another opportunity is, or another possibility is to use an as-built joint between the entire beam and the top level origin. And that would also fix it in position. And you can see that there's really no geometry in the entire beam yet, right? That in geometry comes later after you've put in some subcomponents. But the entire beam has an origin, and that's what that rigid group joint and the as-built rigid joint work with. It works on the origin of parts. No geometry needed. So, but in this particular case, that's a standalone design, and we'll just ground it. We're not going to use this 1010 assembly or design and insert it into another assembly. If that's the case, I would actually use that as built joint, but I don't think that's the case, so we just ground it. And it's much nicer to have an assembly grounded at this level, because that way you can see it in the viewport in the browser that this is grounded and not some subpart that you have to track down first. All right, so let's go on. You create another component, entire rail, and I also would use an as-built joint between that and that, because I know already from your structure that all these parts are already sort of built in place, right? So the entire rail also has a subpart, that's the actual rail, and before we create geometry, I would do that same thing again, as built joint between the rail and this origin. Always the next level up origin. So you basically build a chain of joints between all these origins with this, what's it called, as built joint. So move forward. We have actual geometry. You put a joint origin there, I know why. That ground, we don't need that anymore, because the part is ground in place. Well, actually, the part is joined to this origin, is joined to this origin, and then it's grounded here. All right, the carriage, and I'm not going to do anything with that carriage at the moment, because I know the rail and the no, that's okay, because I know that the rail and that assembly are going to be static, but the carriage is a moving part that consists of more subparts. So I'm just going to click forward and expand this so I see when I'm done with it when I'm done with importing all these components with their base features, and let me just zoom in, there it is. And there we create the second carriage. So at this point in time, that carriage is loose, it's not assembled. That carriage is loose and not assembled. Maybe loose is the wrong word for that. So let me undo this. So because there's nothing moving within that carriage, I right-click on the carriage and give that a rigid group. So that selects all these parts. But yet again, you see I have 11. It says 11 are selected. I have only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 components. But I also have this origin. So that means that origin now is involved, right? So you create proper assemblies when you start managing your origins or your component origins. So now that assembly, that carriage is a complete assembly. And because that carriage already sits in place where it needs to be, what I'm going to do is I'm going to use another as-built joint between the carriage and the rail, and then I just have to pick the right joint, and then I have to pick a straight line here and a snap point on it, and for whatever reason it doesn't animate, but it's a proper sliding joint. All right, so the next thing is the next carriage. So because this carriage is a copy of that carriage, now it's already assembled properly within itself. So I do the same thing. I create a as-built joint between that carriage and that rail, and I'll pick a point there, and I've got my sliding joint created. So let's undo that and move forward. All right, there's a beam here with geometry in it, and I can move to before the geometry is in it and do the same thing. I use an as-built joint between that beam and between the entire beam. But that needs to be a rigid group or a rigid joint. So technically, between the as-built rigid joint and the rigid group, the only difference is with the rigid group, there are more components involved. But other than that, they do the same. So there's the rigid beam body. And now the only thing I can move and should be able to move is the sliders. So you attach another joint origin, a few ground features, an unground feature, and we don't need those anymore. They'll be deleted. All right, so there is that front brace. We can collapse that. There's that front brace. And generally, I would build a frame from aluminum profiles differently. It's much more efficient and easy to dimension than what you do here. Although what you do is, there's nothing wrong with it, it works. What you do then is, I guess you use the align feature or the component move feature and move those into place. And then at some point in time, you use the rigid group. I don't even see that in the timeline where that is. But that's not a good idea. As I said earlier, when you join things as soon as they show up in your assembly. Unless it's something imported like a carriage that has many subcomponents. But in this case, that thing should be joined immediately. And it should not be with a position capture feature. Just use a regular joint. So this is a 20 times 40 profile. And let me move it minus 20 this way. and minus 20 this way. And now it's properly placed into space. So then you create a construction plane, a plane at center zoom, and then you mirror that piece. I personally wouldn't do that because mirroring this piece means, if it's truly an identical piece of aluminum profile, then you get two entries in the BOM, both with a quantity of 1 instead of getting one entry with a quantity of 2. That might not matter to your assembly. I just want to point this out. You later on do the same thing with this here, with the entire beam. But again, I wouldn't do that. Also, I'm not actually sure when you mirror a complete assembly. I don't think it does. It does not copy the joints. Whereas if you copy paste an assembly and join it with regular joints, then it'll carry all the joints with it. So that's a second disadvantage if you mirror a complete assembly. Oh, yeah, I mirrored this, but it's still floating in free space. So what I am going to do, I'm going to use a rigid group, unselect include child components, and I use this and this in that rigid group. All right, properly assembled. And there's a V-slot thing. Where does that go? Oh, come on. Did I click the wrong button again? I think I did. There's the V-slot. So where does that go? Oh, down there. All right, same thing. We're not going to use this position capture feature. We're going to join it properly. Flip and 20 minus 20 and then that extrude to object feature also works perfectly. Then you create another construction plane and you mirror more stuff. Let's see what you're doing there. Oh, yes, that one. Well, what is this? Yeah. Oh, let me see if it's true what I said. The entire beam, yep, it doesn't have any of the joints in it. So that is something I would definitely redo, because the subcomponents also don't have the joints with them. So that would mean double work for you now. That wasn't a good choice. So let's undo this. Okay, what did we do here? There's a second V slot. And the two, they're identical. This is basically assembled here in the middle. So yeah, we're going to do the same thing here because it sits in the middle. Where's my start? Here, okay. Because it sits here in the middle, we'll just actually, here's the middle. And flip this around, move this -20, and say okay. I think it's supposed to be in the middle. Let me know. And then there's another joint origin. I don't know where that sits. There. Okay. Don't need that at the moment. And there's a position capture, and we don't need that whatsoever. We'll delete that. And then you copy that over. You know, anyway, what I said earlier is that'll probably destroy the rest of your assembly if you change this now. But I would venture a guess that that makes a lot of sense at this point in time. So I'll conclude this video for now. Hopefully this has been helpful so far.